Okay, we're moving on to 6.5. So, why do we need 6.5? Okay, here's the thing. We do a really long truth table, sometimes 16 lines. I showed you guys one in the last video. And trust me, they get much larger. And you're only looking for one line. You're only looking for the one line that will give you a true premises and a false conclusion. So I'm sure as you guys have been doing some of these, you're wondering, why am I doing all these lines when I only need to look for one? And you're right. And that's why we have a shortcut way. And just like in your math class, we teach you the long way, and then we teach you the shortcut way. Okay, so here's the shortcut way. You set it up, do your dashes between your premises, 2 dash to say it's a conclusion. And what you're going to do is you're going to try and force it to be invalid. So that's why I have true, 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 false, because we have 3 premises and 1 conclusion. If I can force this to be invalid, it will be invalid. If I can't, then it's valid. Okay, now how do you do that? It's pretty straightforward. Okay, look at the first premise. We got premise 1, premise 2, premise 3, and conclusion. First premise, we have a horseshoe, and it's true. Okay, now if we look over here, there's 3 times that a horseshoe is made true. That one does not help us. Moving on. Second one, it's a conjunction with a true. There's only one time you get a true with a conjunction, and that is when P and Q are both true. So we already know that A is true and not O is true, and that makes O false. Okay, so the dot with the true, there's only one time you get a true with the dot, and it's right here. And then I looked over here, and they're both true. Okay? So that means we just forced A to be true. So we got to fill that in, because it's not like it changed on the truth table, right? It stayed the same on one line. So if A is true, then not A is false. Okay? So we got this one to work. We done with that one. Now we also know that O is false. So we can put the O over there. Okay? Now, we have to move on. Where should we go? Let's go back to first premise here. Okay? So Z we don't know. That one is a question mark. We know it's a horseshoe. And we know that not A is false. Okay, and of course we want to pay attention to the not A, not what A is, because it has a tilde. We also know we need it to be true in order to force this to be invalid. We also know the beauty of logic is Z is either true or false. Okay? So that means if true, then false would give us, well, if true, then false would give us false. That's not an option. If false, then false, well, let's see. If false, then false would give us true. That is our only option. So Z is forced to be false in order for the first premise to work. Okay? So now that we know that Z is false, we will simply fill it in. Okay, now we have a new one we can work out. So now we have not M, horseshoe, Z. So we don't know what not M is yet, so we'll put a question mark. We'll put a horseshoe because that's what it is. We know it's false, and we know it needs to be true. And if you guys will notice, it's the same problem. So we already know what not M is. Not M has to be false because we already figured it out over here. So that is M has to be true. Okay, we got that one to work. Now, we're going to fill this in. So not M is false. Okay, now we have to make sure this is actually going to work out okay. So let's go up here. So we have a biconditional. So we're right here. And we have false and false. And if you guys will notice, that's actually true. So that means we have a contradiction. As a matter of fact, it just will not work. So we now know that if we were to do a long truth table, we would never find a line where the premises are all true and the conclusion is false. It's impossible. That's what we just worked out. So if it's impossible to make it invalid, this argument is valid. Okay, let's move on to the next one. So again, we're going to force it to be invalid. This is the way you set them always up. Dashes for your premises, 2 dash for your conclusion. Okay? So we're going to ask the same question. How many times you get a true with a horseshoe? And it is 3 times. How many times you get a true with a triple bar? 2 times. I haven't been forced into any situation yet. Premise 3. How many times you get a true with a horseshoe? 3 times. We're not forced into anything there. Okay, conclusion. We have a horseshoe and we have a false. Getting interesting now. Okay, so we're looking at this column right here. We need it to be false, and now we're noticing there's only one time it gets false. So now we know that Z has to be true, because that's what that is telling me. And not A has to be false, which makes A true. And we got that one figured out. Now we need to backtrack. Always remember to fill it in. So we have Z is true, so not Z is going to be false. And A is true, so we'll put that one right there. Okay, so now we need to go back. I'm thinking premise 2. At least we got some information now. So we have a triple bar. So now we're going to be down here. And we need it to be true. So we're basically these two. And we know that one side is false. So that means that is not an option. It has to be this one right here. So that means O has to be false. Okay, we got that one to work. So now we want to go fill it in. So, oh, that's our only O. That's unfortunate. Okay, we'll keep working. All right, so we got Z here is false. We know that from, oh no, wait, my bad. Z is true. Read the wrong line. Okay, so now let's work this one out. So we have a true, we have a horseshoe, and then the not M is the one we don't know, but we know we need it to be true. Again, the beauty is not M can only be true, or it can be false. That's the only options. So we have if true, then true will give us true. That's totally fine. If true, then false, that'll give us false. That's not an option. So not M has to be true. It's the only way to make that one work. Okay, now that we got that one worked out. So if not M is true, M is going to be false. So M over here needs to be false. And let's see ultimately if this works out. So we have false or true. That will give us true. We do not know what R is. So we're going to have antecedent is true right here. Horseshoe. R, we do not know, but we know it needs to be true. Again, we have the exact same scenario, so we already know that R must be true. Okay, this one we got to work. Now, why is this one different? Because we were able to find a line where we can get the premises true and the conclusion false. So what this means is, if we were to do a long truth table, then on the line where Z is true, A is true. M is false. R is true. O is false. This one right here, over on the side where we do this, that would be the line that you would find invalid. Okay, so when you force it to work, it's invalid.